Well, hi, good morning. Thanks so much for joining me and my cat Shadow here. Today is February 25th. It's been a couple days since I've been in my shop, and I've had a couple of days to think hard about what's going on with this radio. And I have a couple ideas of what I want to try with it. I think the problems still are around this transformer, but maybe not the transformer itself. I don't really know, and I hope to find out today what's going on. So a couple of times on my scope I had a display something like this, and I was scratching my head wondering what's that all about. So in thinking more about this, I think what this is really all about, if my scope had a wide screen on it, I think we would have seen this going on, something like that. And what's really happening here is there's a primary and a secondary in the transformer, and this is one and this is the other. And their resonance point is way off. They should both be on top of each other, so you can't even separate the two of them. You wouldn't see them as individual peaks. So what's happening here? So I think there's a good chance this is over here because of the way I had the equipment connected. I connected the input and the output right to the coil leads, essentially, probably disturbing the arrangement. And I didn't recognize what this was saying at the time when I was looking at it on the screen. So I think that's the situation. So what I want to do is I want to repeat this test, but instead of trying to inject and take out the signal right from the coil, I'm going to try to inject it into the grid of the tube ahead and look at it on the plate of the tube afterwards. And that'll isolate my equipment away from the transformer, and we'll be able to see what it looks like. The thing is, the radio has to be operating. I did this with the radio not operating. Now the radio has to operate. This is tricky too, what I'm going to try to set up, but I think it's worth doing. If it works, and if it turns into what I hope it would turn into, I should be able to align the transformer right then and there, or at least get it much closer. And considering I certainly have dialed up the screws up here, something pretty terrible. So I take a few minutes now, and I'll try to set up that equipment and get that working the way I want it to. Okay, here's what I've done with Shadow's help. How did I move that wire out of your way there, cat? So I have the scope hooked up to the plate terminal of the 6K7. So whatever the 6K7 gets on its grid is going to show up on its plate. We'll see it on the scope. The scope. And just cutting the output down on this. The sweep generator should still be just sweeping through the IF kind of closely. Go. Okay. Oh. Someone. Oh, who's here? Who's here, Shadow? What's she looking at? Come on. Come on. Push your way in. That's it. Come on, you can push it. Come on, push harder. Oh my gosh. Come on in, the other one's in here too. Tail shaking cat here. There, see the other cat's over there. Yeah, sorry. I'm probably gonna have to stop for a few minutes, just at the point where I'm going to do this big experiment, because this guy wants some attention and I can't ignore him. Isn't that right? Oh, that was kind of funny. My other cat was looking at this cat in the TV monitor, wondering what's going on. Kind of a... Okay, so I'm going to put you down, cat. Okay, and he's on his way. He knows where we're going. To the couch. Just before I carry on here, I think I want to give you just a little quick COVID update in my area because something important is happening. So here's North America. I live right in this area of Ontario here. Ontario is this province. See, 15 million people live in Ontario. Most of them live right in this area here, down here. In this area, guess, it's pretty empty of people. Okay, so we'll zoom in on my area. So here's the city of Toronto, 3 million people living in this area, and there's heavy populations all the way around the end of the lake here, and all the way up through here, and up into this area. This is all farmland here, and this is all cottage land up in here. And I live on the edge of cottage land in Aurelia, right here. So, I'm a distance from the big city down here. But there's another big city not too far away. It's not nearly as big. It's the city Barrie. Barrie is the focal point of COVID in Canada right now, I believe. So that's like a 10-minute drive between Aurelia and Barrie. Barrie has 125,000 people in it. I think I heard this morning there are, I've forgotten the number now, over 1,000 suspected UK variant cases in Barrie and the area around it. That makes this the hotspot in Canada, as far as I know, and maybe even the hotspot in North America. I'm not sure about that. No one's quite sure what's going on with these variants, of course, because there isn't enough testing to really know for sure. So yesterday, my wife traveled from Aurelia to Barrie to get her hair done. This morning, when I got up, the health official responsible for this area here, this whole area, is calling for a lockdown. At the same time, our provincial government, the government in charge of the whole province, is lifting the orders. So it's quite a tense moment here. Is it basically an outbreak happening in Barrie of the UK variant, and it's just getting worse, and it's pretty scary. So that's the situation here. My wife got her hair done. She's back in Aurelia. We're not going anywhere now, and it's kind of scary in a way because the word is the UK variant is uncontrollable, and as much as things are going down everywhere in Canada, similar to the United States, going down rapidly, in this area, it's going up, and that's a sign of things to come, I think. So unfortunately, that's the situation. If our situation here was average, I wouldn't mention anything on my video. But because it looks like something extraordinary is happening right in the area I live in, I thought I would bring that up. Okay, let's get back to working on this radio. So I've hooked up the equipment here. I have the sweep generator. I think I was just about to check the sweep generator settings and make sure it's going where I want it to. So this is 430 up to 490. That's good. That's going right through the IF frequency. The sweep on the scope is coming from here, and I think we're ready to go. So I'm just going to check a few things here. It's been a couple days. I think everything is. Oh, we got to turn on some power here. Okay, so we're going to feed power to the radio through the dim bulbs there. Good, everything's okay. And away we go. And my scope just drifted off there, even though I have the AC setting. So that's the B plus showing up on that tube that I'm hooked up to. Okay, now is this working by some wild chance? That's kind of odd. I changed the volume in the well, maybe not. To make of that. The volume's at the far end of the radio, and I'm up at the front end up here. Ooh. We'll We'll turn up the sweep generator now, which is sweeping right now. What do we see? Okay, let me give it some power here. Not seeing anything at all like what I would expect. What am I doing wrong here? So we're sweeping the IF frequency through the primary on grid 3. Then we're trying to look at it on the plate of the first IF tube. That makes sense to me. Zero curve there. I'm frozen here with my hand in the air. Well, yeah, this is on the antenna. Let's get that off. No need to have that there. We're feeding the radio with 109 volts. That's more than enough to make it work. Just to be clear, what I expect to see up there is basically a line and then like that. That's what I expect to see on the oscilloscope. It's kind of overwhelming, the output of my sweep generator. Of course, I've got the sweep generator cut down too. Let's do this. We'll turn this way. We'll tune this up away from that a little bit. We'll introduce this signal here big time. And we get that. Did anybody hear the hum coming out of the speaker over here when I did that? That's curious too. A very low hum. I'm going to expand the sweep way out from where it is now. We'll stop this. We'll set this to starting at 325. I'll have it stop 580. So capturing quite a bit more space on the scope. There's a resonance way down here. Let's take this down even lower. There it is. Oh my gosh, finally we have it on the screen. But it's nowhere near where it should be. Let's see if we can reason this out now. We're starting at just above 100,000 cycles. We're stopping at just under 600. So it's 100, so it's about 500 altogether range. Sweet. 100, 600. So that's 5 pieces. That's every 2. 1, 2, 3. So it's 100. So 100, 200, 300 kilohertz is where the resonance is. 300 kilohertz. Now I have the oscilloscope hooked up in a stupid spot. Could be causing some of this. No, there's 2 coils in there that need to resonate. Is this one or is this both of them? The set is still on. I'm going to move the scope back to the plate connection here. Very similar thing. Well, we've gotten somewhere finally. Next step would be to turn the screws on that transformer. Interesting, eh? think what's happening is you're driving things into non-linear operation. Like this is linear operation for the most part, and when I get it big enough, a bunch of non-linear things start happening. We get all these weird harmonics and very interesting shapes on there. So we'll keep it down. Some other interesting things going on the oscilloscope there. You really would have to look with your eyes, but there's some indications of other frequencies interfering. There's one here, there's one right here, like two sidebands almost. Another one here, another one here. I don't know what they are. That's about the best looking version I can get on my scope here for you to look at. So some things of interest. This line here that you can see, you can't see it, but there's another one here and another one here, and there's one coming right down here too. What are those? They strike me that those are other locations where there's another interfering frequency of some sort, signal of some sort. You know, why the unusual pattern in here, I don't know. Now here's what happens if I just tune the radio itself. So that's now all the way to the high end of the band. And we'll tune down. So I see those things I was talking about are moving as I tune. Now the shape is just changing. Now what is happening right at this point here? Right here. I have the radio tuned to 1 megahertz. Let me just hang on a sec here. Grab the wrong control. Well, that's interesting. Now I changed bands. So this is a short wave. Wow. Still stuck at the same frequency though, the 300 kilohertz broadcast. Short wave broadcast. It's more information, but it's just not, it's not going into my head in a way that's useful. It's just kind of nice looking pictures on there. What I'm expecting is to see that exact shape, but at 455, not where it is. And where is 455 on there? So it's 600 at the top, so 455 is going to be over here somewhere. Quite a ways away. There's no sign of anything happening. Oh my gosh. How can that be? How can there be nothing going on? How can there be something going on at 300? How? You got me. What has happened here? Oh my gosh. We're looking at the SDR now, and for an antenna I have a small coil, and the coil is quite a distance from the radio, about 2 feet from the radio. I'm going to put my hand on the coil. You see the small change there? That's the influence of my hand. And I'm going to move the coil towards the back of the radio, just towards the center of the back of the radio. You know what frequency we're looking at there? That's 9. We're in 9 megahertz area on that SDR. The radio is operating on the broadcast band. It's producing these kinds of signals at 9 megahertz and everywhere. What a schmozzle. And I don't think this is anything too unusual. I think that's what goes on a lot of these radios. Just moving the coil around from place to place here. A very, very strong one, just below 9. So I'm going to hold it still and change bands. This is on the broadcast band. That's one shortwave band. That's another shortwave band. Not much up on this one. I'm going to move my probe around. Interestingly enough, when we go up to the We'll go up to the shortwave band. I got myself turned around for a minute. We don't see any of this kind of stuff. It's just kind of counterintuitive. Okay, but I'm not interested in this area. It's just another observation. Just more noise to stick in my head, I guess. I'm going to, we're going to change the SDR now so it's down closer to the broadcast range. You can see what's going on down there. There we are. So the thing apparently is resonating around here. It should be something happening here. We should find a local oscillator. Right now the radio's tuned around 1,000,000, so it should be up around 14. Should be up in this area. Move the coil nearby the radio here. Just put it in a spot where it doesn't move. Just a second here. Yeah. Did we find a local oscillator here? I don't see one. Oh, here we go. Okay, so I had it in short wave. So let's go back. Short wave, broadcast, and you can see the local oscillator just jump right up at about 1500. I'll tune the radio just to be sure. So there's the local oscillator, no question, it's there. We'll set the local oscillator to roughly 1455. 14, that's roughly where it is now. Just below. Roughly there. And now I'm going to look at the pointer, and the radio is tuned to roughly 1,000,000. So that's good. Okay, it's all adding up. So what do we do with this now? We hold this up near that. I'm going to hold the coil up near the coil in question. I mean, there's just signals galore up here, but I'll try to make it so. Okay, so wow, okay, big local oscillator coming out of there. Really nothing at 455. Nothing at all. Not surprising, the radio's not tuning anything. Okay, this is really quite a mystery. I'm going to stop for a minute and dream up some other confusing test. So I have managed to find something here. So I took this capacitor out as part of the replacement process, and I put its replacement right there. This capacitor on the schematic is on this screen line. See, these two first tubes get their screen voltage off this line. See, this line gets its supply through this 11K resistor from this supply, which I'm sure is, yeah, it's coming from the power supply, of course. See, they made the line heavy to mark up where the high voltage is. So this is the capacitor. That looks like 1 microfarad. That's capacitor number 25. Now, there's a parts list down here? No, there isn't. No parts list. And this is covering 2 radios anyway, so I'd be unsure. Well, going by this, it's 1 microfarad. That's not surprising. You need to quiet these screens right down, or you can get some weird feedback going on, stuff like that. 1. Now, what was in there? 0.1. 0.1. And what I put in there, 0.1. Is that the whole problem? I'm going to change that to a 1, this one here, to a 1, and we'll see if the radio responds. Maybe that's what this whole problem's been about. Well, lucky me, I have a whole bunch of 1 microfarad capacitors, but their voltage rating is only 250 volts. So I need to find out what kind of voltage duty is going to be in here. It's a screen, so it could easily be more than 250 volts. So we're going to have to measure it before I subject the capacitor to it. But I would like to use these. Look at how many I got. You know, 1 microfarad capacitors are expensive, guys. This is probably in there because this is the biggest thing the guy had who did the work previous to me. This is probably the biggest capacitor he had, and it looks like it came out of another radio because the leads were, well, I won't say that. Not necessarily the case. It may look that way, but that's only how it looks. So I want to make a voltage measurement. I'm going to remove all this equipment here before I get myself into extra trouble. Trouble's okay. It's the extra trouble I don't want. Everything off. Okay, everything is off. Voltmeter. I think we're going to be reading just between. It's going to be front. No, it's going to be to the chassis. So we can use my indicator meter here. TTDN. Too much. Too many cables here. Okay. Generally don't like to show all my house cleaning on videos, but I do like to keep these as close to being live as possible. So, as reasonable. Where are we at now? So now we're going to put this, we're going to use this meter. Let's just do it right. Put this on here. That's because one side of this capacitor is on the chassis here, so the voltage across it will be read to the chassis. If this lead had to go somewhere else on the radio, I wouldn't use this meter. I'd use this one because it's completely isolated. This one, yeah. I guess we got to turn the radio on. What am I waiting for now? I'm waiting for nothing. So I ate insufficient coffee this morning again. I'm only halfway through my first cup. Okay, first let's check and see what kind of voltage is in here. 500 volt scale on my meter. Go right on here. So that's just under 300 now. What are we feeding? Well, we're feeding the radio 108 volts. Well, let's get this up a little higher. Go a little higher than normal. The radio is running on 118. That's not that much higher. There we see 300 volts. Possible. What is across that capacitor? Not very much. Hold on. 100. 100 volts. Let's go to the 150 volt scale. Yeah, 100 volts. Yee-hoo! I get to use my blue. Turn the power off before I forget. I get to use one of my blue little capacitors. So it's going to go in this position here. I have to solder little extension leads onto it. Okay, let's get that installed and see what happens. That turned out to be really easy. So I found another ground connection here. I just soldered it in, short leads and all. I almost soldered it in, short leads and all. I just need a little more solder there. This is where the solder comes in handy. There it is. You could probably see it, but I couldn't. I think that happens a lot in here. You know, my angle of view is different than the camera. There could be times where things are plainly in view in the camera, but they're hidden from my view. I'm doing this in the dark. There we go. That got it that time. Very good. Yeah. Will this radio work? Now I've got no equipment hooked up to it, so we're going for the full Monty here. Put an antenna on it. I did look into this arrangement here. It's satisfactory the way it is. I'm still not fully sure about this. I mean, this is just the shorting thing that's missing out here, installed out here. It's just the same thing. It's not doing anything unusual. This is. Okay, that's an outdoor antenna. I'm going to turn the radio on while it's warming up. I'm going to run and turn on the antenna, make sure it's on down here. Are we all set? Looks that way to me. Okay, volume's down a bit. Back. I've been monitoring short waves a lot the last few days. Not very good. It's not very good right now. Okay, 88 volts on it. Let's go. I need the full voltage here. And now, a moment of truth. Turn it up. And the truth is, nothing there. Now, remember, I monkeyed around with this tuning here, something terrible. Nothing. Change bands. Nothing. Well, I wasn't very hopeful, to be honest with you, that that was going to do anything for this radio. Didn't do a thing. Let's just check a couple stuff here. Looking at this meter, checking to make sure we still have big voltage up here, 110 volts. And on the IF amplifier tube, that is the IF amplifier tube. That's the now, did you hear that in the speaker? The little boom boom boom. Very subtle. We got 300 volts on the plate, 100 on the screen. Sounds reasonable. We don't hear that at all. Wow, this radio's in bad shape. So I'm going to revert back to signal tracing, and we're just going to try to follow the signal through this radio from the antenna and see what's happening to it. So I kind of changed my mind, decided I would pursue this from the audio, from the speaker back. So the first thing I'm trying to do is inject a simple audio signal into the grid of the output tube here. Radio's on, it's on full voltage here, 118 volts. This is the output from here. See, I very cleverly did that. Let me get this. I'm going to stick this now onto the grid of the output tube. The volume's full, but it shouldn't matter. Actually, the volume is not full, but it shouldn't matter. Output tube, here we come. Can you hear it? Just barely. It's about 3 kilohertz. So I'm putting out just about as strong a signal as I can out of this signal generator. How strong is that? I don't exactly know, because I don't usually use it for audio, but I do have one I do use regularly for audio. That's this guy. And you know, he puts out a fairly substantial signal even with this low setting. And I know that right now that signal's on these wires because I checked it. So now we're gonna ground this to the chassis. We're gonna connect to my probe here. Okay, now we're gonna probe in the audio. I don't know how loud this will be. Just give it a little tap here and find out. Okay, So it's a little louder. It's a little more juice coming out of that. So now we're going to switch to the grid of the tube that's feeding this grid I'm sticking the signal into. That's this. Okay, so if you can get a signal there, similar in level to whatever's on here, they should come out the speaker. So I'm not going to really think that there's any problems beyond here. I mean, we don't know about the level. Maybe I'm blasting it and that's why we can hear it. I don't think that's the case though, from my experience. I think that's quite acceptable. If we go back another one, well, I got to switch. I got to switch to 455 kilohertz. Let me stop for a second, get that ready. Okay, I think we're set. So the frequency generator here is running at 455. I've got the max signal coming out of it. It's coming out, it's on this probe. I am now going to stick this probe on the grid here, and we should hear this. I've got a 400 hertz tone going there. You should hear it. Hear a very hummy rumble. Could be that I'm grounding this in a not the best spot for this kind of thing. That could be causing a hum to get in here. Certainly don't hear the 455 though, at all. What's happened here? I mean, it should go through. In fact, I should be able to remove that grid cap. Is that right? Yeah, I should be able to remove the grid cap. Yeah, let's do that. Hi. Yeah, I'm feeding a better signal than the what? Come on. Apparently, I'm a better signal generator than the signal generator. Figure that out. How can that possibly be? What's going on? Let me put this down. I'm not holding on to any wires anywhere. I'm going to turn down the signal strength on my generator. I guess I'm just a really good antenna here, able to pick up the signal generator signal. Better than making a direct connection? How can that possibly be? What funny thing is going on now? What have I done? I've done something dumb here. So what I've done. Let's see what I've done. No, it's not the dumb thing I thought I did. I don't get it. Oh, maybe I do get it. Oh, 2 probes. I think I was wielding the wrong probe. Okay, now we're ready. This is definitely the right probe. I'm better off with the wrong probe. I'm no longer a good antenna. This is just the weirdest stuff. Weird stuff. So really, it should have come through. Unless this transformer is way out of whack. Now, I think I adjusted this one. It went just fine. Why would it be? I was going to pull that grid cap off, wasn't I? I kind of got waylaid on it. There, that's good enough. Ooh. Put the signal back in. Get the right one. Nothing. So there's another problem here. Okay, review everything. Radio's on. Voltage at 118 volts. Tubes are heated. The signal generator's on max output. No, it's not. It's not. It's on quite low, actually. That might make a big difference right there. Okay, so now we can hear something coming through, but it's an uncalibrated test, so the volume is cranked up full. You just think a lot more would come out of this radio than this little bit. Okay, so what happens if I try to pass 455 right through the 455 transformer? So we're going to put this back here. And tubes get hot. Okay, that's connected. We'll check it. Yep. Now I want to try to feed this signal. You know what? We can feed it into the grid of the 6A8. It doesn't care, and it'll come. It should come through. It should come through to where? Wait a minute. It should come through to the speaker. That's what we're listening to. Okay, here we go. There it is. Now, how different is that? Well, it sounds exactly the same. Kind of as if this isn't doing a thing. Okay, so now we fed it through this tube here. And get a surprising result that it's not amplified. It's not amplified by the tube or anything going on. Just sounds exactly the same. The when I sort of scope the response curve for this, I get just a straight bar indicating to me there's no resonance in it. Oh my God. What is wrong here? Everything is wrong. By the way, I spent some time double checking these capacitors I put in. These are satisfactory. I really didn't finish this one very well, because there was a lot of confusion when I worked down in here. But I'm pretty sure it's all correct now. And that doesn't mean a lot, does it? So I'm going to check this stuff again. Oh my gosh. So early on in my testing, when I was checking voltages, I found a minus 24 volt voltage. It was actually reading minus 50. And so I'm thinking, well, maybe that has a factor. Maybe that's a factor in this. The minus 24 is supposed to be on pin number 1, 2, 3, 4, 5. Pin 5 of the 6A8. Pin 5 of the 6A8. Pin 5 of the 6A8. Pin 5 is the control grid, so it's receiving the signal from the oscillator. So, does it matter? Let's read it now. Read it with this meter. Okay, we're on the 150 volt scale, ready for a negative reading on pin number pin number 3, wasn't it? Ah, 8. 5. Pin number 5. Pin number 5. 6A8. Pin number 5. My lamp has given up the ghost here. Doesn't want to stay up anymore. Moans and groans, just like me now. Okay. 5. 1, 2, 3, 4. So 5 is here. What happened to the big negative voltage? Did I not clip this on? Yeah. That's interesting. Let's go check that again. 1, 2, 3, 4, 5 has this resistor on it. It's a tiny voltage there. That's a 50 volt scale. That's like 1 volt. Not even. No, it's 5 volts. 5 volts. And we're looking for minus 24. Let's try that again. Okay, so this is a shortwave band. I believe what we're looking at is strength of the oscillator. Ooh. Lots of juice there. So it still has the over 50, but you know what? These readings are taken on one band. They're taken on a shortwave band. No range switch shown in shortwave position. Now that's crazy. There's 2 shortwave positions. So I'm going to guess one of them they're going to call. Well, let's see, what are they actually? From 6, and the other one is from just above the broadcast band to 5 megahertz. And the other one is from there all the way up to 17. So we're gonna think it's probably the second one, like that. In that case, now we are looking for the 24 volts, and we tap the proper thing, trying to remember what it is. It's this one. Wait a minute. So there's 24 volts. This is in the other shortwave band. Let me tune the radio, and right now we're in the middle of the band. I'll just tune it and see what happens to that. Well, where to go? Oh, wow. Look, the impression I get from this, you can't see what's going on here. The impression I get from this is the oscillator's not even working on this band. A little bit there. It tried. But on this band, if I get that, and if I tune now, ooh, baby, look at it go. I've never paid too much attention to oscillator outputs. I probably should be doing that a lot more. So my experience in this area is not so great. And we get this nice big voltage up here, which likes to stay way up there. Here it's coming down a bit. Does that mean the radio works better down here? Does it work better? Does it work at all? All that's done with the volume up totally full. We didn't hear a single sound come out of this radio. Feeding it with 118 volts. Signal generator here, but this is RF now at the IF frequency. So we stick it in the grid here. And we hear it. But I think it should be blasting out of this radio. Like the whole radio is generally depressed. Kind of like me. Wow, I really thought this was just gonna, as usual, I come in here very optimistic that I'm gonna wrestle this thing to the ground. I didn't get anywhere here. Like I don't have any better sensation of anything here. Well, you know, so I was doing signal tracing. I did the audio signal tracing back, and what I seemed to find is very weak output, no matter where you inject the signal. Obviously, if the amplifier is weak, it stays weak while I fool around at the front end. So I could be producing signals that are getting to a weak amplifier and we can't hear them, and I'm thinking nothing's happening when stuff is happening. You need to monitor the signal, the sound, at the detector and listen to it while I'm working. I know a couple ways of doing that. So that's one way forward. Listen to what's coming out of the radio itself. That's easier said. That's easily done. I do that right now. Very easily done. I'm going to try to listen to the output of the radio part of this radio. I have the signal tracer set on audio. Where do you want to try to get it? We listen to what's making it to the grid of the first audio amplifier tube. Swing this further. And what are we expecting on hearing here? What am I doing? Am I sticking a signal into the radio? Not really. Sending in a signal at the IF frequency. There's an IF trap in this radio, so that's no good. We want to send a signal in at the signal that we're tuned to. I'm going to tune it up around 1,000,000. 1,000,000's a nice round number. Okay, tuned to 1,000,000. Now we'll tune my signal generator also to 1,000,000. Not a sound. Have I hooked up to the antenna? Radio's, what band are we on? We're on the right band. Put this up. Full. Okay, it's giving it all it's got. Nothing. Okay. Where can we hear the 1,000,000? Do we hear it here? We do not. So we switch the signal tracer now to hear the IF frequency of 455. What's making the noise here? Just like I get out in the middle of nowhere. Maybe it's like a dipole antenna, and getting it farther away from the ground lead when it picks up stuff. I don't know. Who knows? Okay. RF. We would hope it would be here. Now, don't give up yet. So we're feeding in 1,000,000 and we're trying to pick it up halfway through the IF. I got to tune my signal generator here. Come on, man. Anything. We should hear a 1,000 hertz tone. So it's not getting through here. I better check to make sure the radio is really tuned around 1,000,000. Yeah, definitely. So it's not getting there. It should be at the output of the 6A8 tube. The output of the 6A8 tube. It's going into the primary of that coil. It's right here. Let me turn this down a bit. Bit of a pop here. There it is. Lordy be, there it is. Let me okay, that's rated 455. It's bang on. Now if I tune the radio, it should come in and out. Oh, it's doing lots of weird stuff. There it is. So the radio's working up to this point. right here. And it goes in that coil, never comes out again because it doesn't appear up here. You know, that's got to really, really, really prove that the coil's in trouble. The transformer. Seems to me I started my day out knowing that. I think the coil's got to come right out of the radio entirely and be inspected on the bench and checked. It's not something I want to rush into, so I'm going to stop, think a bit about what the next easy steps are before I get myself into a bigger and bigger jackpot here. There's 3 wires to unsolder at the bottom. That's not a big deal, I think. Out it could come. For what benefit? That's what I got to get clear. Maybe I should have done this right off the bat. So what I'm doing is I'm testing the primary and the secondary. The primary with the ohm meter looks fine. Secondary, maybe not. So getting on one leg here and the other up here, and this should look like pretty much a short circuit. And 0 happening. Maybe I'm on the wrong terminal here. Unfortunately, they have a whole pile of black wires all piled up on top of each other here. And in order to see what's happening, I have to use my X-ray vision. This wire, where's it going? Oh yeah, it's going over to this terminal. I thought it was going here. Ooh, that might have fooled me a few times in the course of doing this. Okay, so now take our ohm meter. Here we are. This is let the truth be told. To here. 0. Well, a little bit of resistance. So this is telling me the coil is connected. Now the problem with doing the primary is there's still a voltage sitting on it. So what I did was just read one side and the other to the chassis. Let's see if the voltage is still there. So this is one side of the primary here. Oh, it's gone up. That's strange. 8 volts. And if we go on the wherever the voltage is coming from, we go on the other side of the primary, and there's the 8 volts. I mean, is it possible? Well, oh, well, if this is open circuit, I would see a voltage between these 2 terminals. And even with the voltage there, it's the same voltage. So I think I can still make a valid resistance test. Maybe not the number, but in terms of conductivity and that, from here to here. So it's really convincing that these coils are okay. Let's go to 200 ohm. See if we can actually read the resistance here of the coils. You should see a difference. Here. Complete 0. Well, we saw those coils. We saw how much wire was in them. Another possibility here, I was thinking about this and kind of forgot about it till just now. So we're going to read the secondary. It's up here. 0 on that too. Just the resistance of these coils just may be so low as to look like 0. And now resistance between them. Resistance between them. I didn't do that. So here's one coil, and the other can be accessed here. And it's just open. wait, no, I'm supposed to be reading between them. Yeah, there's no short between them. The coils are far apart, the wires are separate. There's no way they're shorted. So I've got the indications that it works and indications that it doesn't work. The stronger indication that it doesn't work. The indication that it doesn't work is the stronger indication. Having tried to feed signals through this thing, getting weird results all the time. The accidental ground to the can. I don't think so. I looked. I can actually look up through the hole here. I really don't think so. But let's see. Because what I think and what's real could be pretty different. That's one. That's the other. So the wires have not touched the can, even though I still have the cardboard in my possession. Well, there we go. Absolutely nowhere's ahead here from where I was. Unbelievable. But we know things are working up to here. I think I got to take it out and really look at it and really mess around with it. Jeepers. I don't know what else to do, really. Maybe stop and think. That'd be a good idea. In the early stages of working on this radio, I went after the power supply filter capacitors. Got quite confused, installed them wrong, and then corrected them. Maybe I didn't quite correct them. Maybe I left one in here that shouldn't be in here, like this one. Maybe that shouldn't be there. What do you think of that now, Mr. Radio? I don't know. We're going to find out. Volume down. Everything ready as if it's going to work. I have nothing connected to the radio except an antenna, really? Okay, here we go. What happens now? What will happen now? So for quite a while I thought there were 3 filter capacitors in here because I got fooled. And that, I only partially unfooled myself because I continued to leave 3 filter capacitors in here after realizing there should only be 2. I sort of analyzed it and thought 2 of them were in parallel. Not this one and the other one were in parallel, so what did it matter? I don't think they were in parallel because I moved a wire after that and they're no longer in parallel. So I think that's how I got into this state. Now I've talked a whole bunch. Is the radio even going to work? Is it going to work? I turn these up. That's the first time that's happened. That's a good sign. Okay, inject signals, but most of my equipment's off here. I will use me as the signal injector. No, actually my equipment is still on. What am I talking about? Okay, so we're feeding an antenna signal in here right now. We're blasting one away at just around 1 million. We don't hear it. Even a little. Let's tune. Come on, man. Just come to life. If I could just get something through the radio. Please. Doesn't want to do it. But we did pick up this. Okay, let's try again injecting 455 up into the IF tube here. I gotta reset this to 455. Well, that was kind of interesting. That's coming out of the speaker of the radio. I even got it even hooked up, I don't believe. So, where are we going here now? All this jumble of wire, I'm going to have to de-jumble this because it's too much for me. De-jumbling, I can get this one out of here. Okay. I have another one. This one here. Let's take it right out of here. Okay, and we can simplify the voltmeter leads. Actually, they're not hooked up to anything either. Get them out. Ow, scare the heck out of me. This is exactly why I want to do this. Everything's all tangled up. Okay, still hearing it. Very reassuring. Don't know. Hey, it's fed into the antenna. Oh, hot diggity dog, man. Ho-ha, ho-ha, we're getting somewhere. We are getting somewhere. Now, yeah, that's pretty good. For some reason, with this switch in the middle position, you know, something to do with this stupid wire. I studied this for quite a while and could not get a full grip on what's going on with this wire. I'll study that some more. There are other ways into the radio though through here. Let's stick with what we're doing. So I'm feeding in the IF. Let's feed in a regular radio signal now, again at 1,000,000. Stop. Yeah, IF going in through the antenna, coming out of the radio loud and clear. Okay, let's go to yeah, my little brain is wearing out here. We want to go to 1,000,000. That's where the radio's tuned. Now we're feeding the signal into this antenna wire. Are we really? Yes, we are. Full blast. Right around 1,000,000. The radio's up full. Come on. Come on. Well, let's go on the band that appears to be working. So that's this one. And that band would be, I'm going to guess, around 3 megahertz. Let me move it a little more. Okay, up around 4 megahertz. That was dumb. Down. No. I'm trying to get the radio in the same range as the Oh, I just hope the heck I haven't had the volume control confused with the tone control all this time. Right around here. Making noise, like there's noises coming out of the speaker. That's really reassuring. So we think we're tuned to 3, but maybe it's 10 megahertz. There's nothing's happening here. Okay, let's go try 10. No. While we're doing this, might as well go to the top band. We think we're around 10 now. There's nothing making it through this radio. There's got to be nothing making it through, and the IF went through like crazy in the middle setting. Is there somewhere I can inject this signal a little further into the radio? Get past all this stuff. So yeah, on the grid of the mixer tube, bypassing all of it. He says, suddenly realizing. Okay, grid of the mixer tube. that up here. Hot diggity dog. How do you like that? That's pretty reassuring. Okay, we're putting in a signal at around 10 megahertz. Which band are we on? That's the whole thing. This is the band with the nice voltage on the meter here. I think it's around 3, might be 10. 3. Just nobody home. 2.9 is that radio's tuned to above 3 on the dial. Above 3. Oh, signal's down. Signal level low. Signal level low. Everything's up. Voltage is up. 118. Everything. We're giving it everything it's got. Hey, what happened? All of a sudden it's a-working. It's like it's just slowly crawling to life on its own here. Okay, so that hopefully proves, yeah, the radio is tuned to roughly 3.2, just like it says. So which band is that? That's the middle band. That's the working band. That's the one, not working band, that's the one with the correct voltage on the tube. We got something working here. Have I gotten too excited? Too fast? What we would do now is put an outdoor antenna on. See what it sounds like. See that? What it should sound like. Oh. That's right, I'm bypassing all this crap up here. You know, maybe what we're seeing here is the last-ditch efforts of a previous repairer trying to get this radio to work. I'm starting in the last ditch and going forward from there. So we're going to replace this signal generator with just an antenna, bypassing the front end, like basically the band switch is what we're bypassing here. Ow! Hot tubes, hot tubes. I thought for sure I heard something there. We shouldn't hear anything down here. This is a crazy low frequency. Here, make life easy. Four. That's terrible, eh? The noise coming out of this. But that's not unreasonable. That could be what is there to be heard on that antenna at those frequencies. Go back on here. Oops, I bumped something, that's all. Here we go. probably, and we're at 3, we're at 4, 4. Wow. Wow. Wow, wow, wow. Wow. Okay. This radio is now showing reasonable sensitivity. I'm on about 100 times 10, about 1,000 microvolts. Not fed into the antenna, but fed into the grid cap on the first two. And this radio is working. So now if we feed the signal into this mysterious wire, do nothing different. Do nothing different. Stone silence. So I think what I'm battling here is a series of problems. Because this should work, shouldn't it? The signal can't get through the band switch even. Okay. It's been a long haul, but I think I'm focused on something. I've got something to chew on now, finally. Thanks a lot for watching and tolerating all this struggle.